In this video, I am discussing the system design of a hotel reservation system like MakeMyTrip, Booking.com or Airbnb. We'll see how the hotel search is very fast, how hotel booking is highly consistent and idempotent. We'll see how the data model looks like and the whole end-to-end scalable design. First, let's start with the functional and non-functional requirement. So the first requirement we have is admin can add hotels rooms. Customer can search hotels and rooms based on location, ratings, types, terms or some search text and few other parameters. Customer can book a hotel room. Customer can list bookings. Here are a few low priority requirements I have added, like hotels and rooms will have amenities. So amenities like free Wi-Fi, spa, gym, swimming pool, if the room is having TV, fridge or mini bar, etc. Next one is customer can review or rate the hotels or room. Next, customer should be notified for all the booking status changes, right? First, the status will be created, the payment can be failed or payment can be completed, then the status will change to confirmed. So this type of status changes, customer should be notified. Next, hotel recommendations. This is an optional one, like when the customer will come to the home page based on the customer's previous booking details, search details, customer can be recommended some hotels. Next, we'll see the non-functional requirements. Non-functional requirements are the qualities of the system or how the system should behave. So the first thing we see here is the CAP theorem. It says the system should be either highly available or highly consistent. But different parts of the system can be highly available or highly consistent based on the requirements. So we will focus on eventual consistency for adding hotels and rooms. So if hotel admin is adding hotels or rooms, it's okay that immediately after adding the details, the data is not available for all the customers. It's taking some time. So that is eventual consistency for adding hotels or rooms. Next, low latency for search. Search should be very fast. High availability for search. Any search or user facing components should be very fast and highly available. Next, strong consistency for bookings. So what this strong consistency means here? Must prevent overbooking. We should not allow overbooking. Enforce accurate availability. Based on the accurate room availability, we should go for the booking. Next requirement is scalable. So you should design the system in such a way that it is highly scalable. Next, idempotency of booking. So idempotency of booking means, let's say user is clicking on the booking button with some parameter, right? Some booking parameter. So once it clicks, one booking information is created, right? Immediately after that, if user clicks on the booking button again, so should we create a different booking ID? So it means basically if we are creating booking with the same parameter again and again, so should we create multiple booking IDs? No, right? With the same parameter, only one booking ID we should create. So that is the idempotency of booking. Next, we'll discuss the entities, the main entities in this system. So we have hotel, room, customer, admin, search. Search is a entity, like search will have lots of parameters, right, based on location, rating, let's say the price range, city and few other things. So search is basically one entity here. Booking will be one entity, and payment also will be one entity with payment related details. Next, discuss the APIs. So the first APIs we can think about is the hotel creation API. So that admin will be creating hotels using that API. So here we will be using one REST post API, that is /hotels. What will be the payload? We need name, category, amenities, address, owner, descriptions, and few other hotel related metadata. Next, admin can create rooms as well. That will be post call again, and that will be /hotels, hotel ID /rooms. and it will have the room number, room type, amenities, room level amenities, floor, and other metadata. Now there will be few other CRUD APIs, like admin can delete a hotel using a delete API /hotel/hotel ID. Admin can delete a room, like delete /hotels hotel ID /rooms room ID. Admin can update hotel using a put API. So for updating a hotel, admin can use put /hotels hotel ID API. For updating hotel rooms, admin will use put /hotels hotel ID /rooms /room ID. This is one important API, right? Admin updates room price for a date range. So when we search for hotels, so we see the rates also in that search result. So how the rates are updated? So admin has to update the rates of the rooms for date range, particular date ranges, right? So for that, admin can use this put /hotels /hotel ID /rooms /prices, this API. So it will take room type ID, let's say it is deluxe room, start date is this, end date, and price is 4,500 for this date range. So now we'll go to the customer related APIs. So first customer has to search for hotels. So for that we'll have a get API, get /hotels API, and it will take lots of query parameters. First one is search text, then city, price minimum, price max, this is the price range basically, the number of rooms customer wants, the number of guests, and also this whole result should be paginated, right? So for that we are using cursor based pagination. So we are using cursor and page size here. So we will have more query parameters here in this API. I have not added all, but if we see like the query pattern parameters are growing, so in that case instead of using a get API, we can use a post API with a request body. Okay, so next we have the customer booking API. So for that we'll use a post /bookings, and we'll have to pass hotel ID, check-in date, check-out date, room type, number of rooms, guest name, number of guests, and the payment info, and also few other metadata. Next we have the review. Customer can provide reviews for the hotel. So for that we need a post /reviews API, and we'll pass booking ID, hotel ID, room type ID, rating, comment. So one question can come here is we have the booking ID, but why do we need this hotel ID and room type ID? Because we can infer hotel ID and room type ID from booking ID itself. So we can do that, we don't need to pass this too, but there are other reasons for that. I have kept it here, that is we can do some validations in the backend whether this hotel type ID and room type ID customer actually mean that is referring to the same booking ID or not. There are other reason can be like to infer hotel ID and room type ID from booking ID, we need to do some joins. So if we want to avoid that those joins, so for that we can use a denormalized request payload. So next I will discuss the high level design quickly. So this is a very high level design. So this is the whole reservation system. This is a black box, and we'll be breaking this into pieces. First I am discussing the admin related actions. Admin can create, read, update, delete hotels and rooms. Admin can update the rates for rooms for particular date and date range. So customer can search for hotels and rooms, customer can book rooms, customer can view the bookings, customer can review a hotel. Next, I will assume some numbers for the scale, and based on that we'll do some scale related calculation. So we are discussing about a large scale hotel reservation system like MakeMyTrip or Airbnb. Like, so let's assume we have 500 million total users, 5 million daily active users, 10 search per user per day, 5 hotel details per view per user per day, 1 million bookings per day, 10 million hotel listings and 10 photos per listing on an average, and 1000 rooms per hotel, which is very reasonable. Next, we'll do some calculation based on our assumptions. So first I'll calculate the QPS and TPS. So QPS is the read, the query per second, and TPS is the transaction per second, that is the writes per second. So we are having 10 search per user per day. So 10 search per day per user is the same. So and we are having 5 million daily active users. So that means 5 million into 10 searches per day. In total we have 5 into 10 power 6. This is 5 million into 10 divided by 10 power 5 searches per second. We are assuming roughly we have 10 power 5 seconds in a day. So this is to simplify the calculation. And that comes around 500 searches per second approximately. Next, we are assuming 5 hotel details view per day. So 5 hotel listing view per user per day, that means 5 million into 5 view per day. So that is 25 into 10 power 6 divided by 10 power 5 views per second, which is 250 views per second. So total we are having 750 QPS approximately. Next, TPS. So we are having 1 million bookings per day. So 1 million booking transactions are happening per day. 1 million is 10 power 6 divided by 10 power 5. That is 10 bookings per second. So TPS is 10. So we see the TPS is less and QPS is higher, right? So this is a read heavy system, and of course anyway we will go for a microservice based architecture here, and anyway the other search service and the booking service can scale separately. We can horizontally scale those services separately. Next, I will discuss a little bit about the storage requirements. So we have 500 million total users. 500 million total users. Let's say 1 KB per user data storage, right? And that means 500 into 10 power 6. This is 500 million into 1 KB, which comes around 500 GB. 1 million bookings per day. So for booking, let's say 2 KB per booking. So if 1 million bookings per day, then 365 million bookings per year, and that is 365 into 5. This many bookings, this many million, 365 into 5 million booking for 5 years. Now if I just simplify this, consider 36 instead of 365, I am taking 400. So this comes around 2000 million bookings, and that is 2 billion historical bookings we are storing in this system. So for each booking data is 2 kilobyte. So 2 billion into 2 kilobyte is 4 terabyte. So we are having 10 million hotel listings. We have defined here 10 million hotel listings and 10 photos per listing. So consider 5 kilobyte per listing, because listing will have descriptions and various other metadata for hotels. So assume 5 KB for listing. So it comes 10 million into 5 KB, which is 50 GB, which is not that large. Next, 1 MB per photo roughly. So 10 million listing, 10 photo per listing, and 1 MB per photo, that is around 100 TB. So now anyways this photos and any static data we don't store in database. We store it in blob storage or in CDN. So if we just see the database requirements, 500 GB, 4 TB, 550 GB. So any modern day SQL database will be enough for our system. Next, I'll do the deep dive. So first I am seeing the search. So how customer will be able to search? So customer can provide some search text, right? So it can be like hotels near MG Road with rooftop pool, luxury suite in Goa under 5,000, hotels within 5 kilometers of Bangalore airport. So you see these are like very text based search, and here hotels within 5 kilometers of Bangalore airport, this needs some geospatial search, right? Location specific search. Also this is every search will have this kind of filters, right? Price range customer can add the star ratings, right? The reviews and the room types, amenities, location. Based on these filters also customer will be searching. So this type of search we need a database that is optimal for search, and we will be using Elasticsearch here. So this is the system for search. So I am using one API gateway, and we will have multiple services, and I have just drawn the search service here. We'll add multiple other services in our for our next requirements. So we are using API gateway. For the API gateway takes care of many things like load balancing, API routing, authentication, authorization, rate limiting, and all this. So now customer can search hotels and room using this search page, and the request will be routed to search service. Search service will read the data from this Elasticsearch database. So Elasticsearch database, as we told, like it's very optimal for search. It stores the data using inverted index, and the newly added data also can be indexed very quickly in this database. Now the question comes is how we store the data in Elasticsearch DB. So that happens when admin adds hotel or room details in the system. So that is handled by this hotel service. Because admin will add hotel or rooms in using this hotel service, and this data will be stored in this hotel SQL DB. So this is the source of truth of hotel related or room related informations in this system. And this Elasticsearch DB is only for search. So, and also the hotel rooms, like room photos and all this static data will be stored in blob storage, and for localization purpose or first retrieval we'll store it in CDN. Now how the data will go to Elasticsearch DB? So we are doing it asynchronously. Hotel service directly is not storing it in Elasticsearch DB. So we are just putting the new inbound payload in this inbound queue, and there is a search consumer that reads from this queue and adds the data in this Elasticsearch database. So this is the main search flow. So now we'll discuss what are the tables in this hotel SQL DB. So the first table we'll have is the hotel table. So we'll have ID, name, description, rating. This is the average rating basically. The category, address ID, owner ID, and created and updated timestamp. So this address ID refers to this address. So this is a foreign key here. Address will have ID, the building number, street, city, state, country, latitude, longitude, etc. Next, we'll have room types. Hotels will have few different room types. So it will have ID, name, hotel ID, and this is the name of the room type, and the capacity. How many of these room types we have in this hotel, that count, and the bed type in this room and all. So next we'll have a room table. So this is to store the actual room details. So it will have ID, the name of the room, the number or name of the room type ID, floor, and created and updated timestamp. Hotels will also have amenities, right, as we discussed earlier. So for that we are having an amenity table. It's having ID, name, description, category, and we have divided it into two tables, room amenities and hotel amenities. It's just having the ID with the room type ID and amenity ID, and hotel ID and amenity ID here. Now next, see in this design, are we missing anything? So in this search service is responsible for the search results, right? So but when we go to the search page, we see the rates also for the hotels or rooms, right? So how the search service will get the rates for a particular date range, and how the admin will update the range. So you already had an API where we saw we'll be able to update the admin will be able to update the date range, update the price for the date range. How admin will add this? So using this API, admin will be able to add this, and where we'll be storing this? We will not store in this hotel SQL DB. right? Because this rates information, so admin will add like for let's say the upcoming 1 month or 2 months, right, or max 6 months, right? So this will store in some other database, and we'll see next how we will be doing that. So here first I have created one table here. So we are having the rates ID, the hotel ID, room type ID, date. So for this hotel, this for this room type in on this date, the price is this, and this is the currency, whether any discount available for that date, if it is refundable and all. And also we have the created and updated timestamp for this rates. Now how will populate this data? So we are having this SQL DB where we will be updating the rates. So because admin will use the update rate API to update the rates, and it hotel service will put the inbound payload in this inbound queue. There will be a rate service that will listen to that at, and it will store it in this SQL database. Also it can store the recent rates in this cache, and search service can access the rates from this cache, and if it is not found in cache, it can search from the SQL DB. Now search is complete here. Now let's go for the booking. So customer can book hotels using this booking page, and also can update hotels, update booking using this booking page. So that will be handled by this booking service. So booking service will have few tables that we are using the same SQL cluster where the hotel rooms rates are stored, and what all tables we need. We first need a booking table, and also we need to keep track of the room availability, right? So to satisfy one booking, we need to see if the rooms are available for that date, right? So that room inventory also we need to keep track of, and booking table, room inventory table, and based on the rate tables we have to verify if the amount is correct and all. So these tables are highly related, and the schemas are highly structured, so we are using the same SQL DB for that. So the first thing we need here is the room availability or inventory table for the booking. So let's add those tables. So I have added this room availability table. So that is, we have this ID and room type ID, hotel ID, date, and available count and total count. So for this hotel, for this room type on this date, there are this many rooms available and total room counts, right? So we should have a constant that this available count cannot go negative, right? So we'll have one more table that is to keep track of the rooms. So it's having ID, the room ID, hotel ID, date, status, whether this particular room is booked or not, and the booking ID. If it is booked, then what is the booking ID for that? Now usually for most of the hotel reservation systems, the bookings are done based on this available count. For this room type, how many rooms are available. So rooms are not allocated at the time of booking. So rooms will be allocated at the time of check-in. So we are following that only here. So this room calendar table will be updated at the time of check-in. But these two are correlated. Next we have the booking table. So booking table will have the booking ID, user ID, hotel ID, room type ID, number of rooms, number of guests, check-in date, check-out date, amount, currency, booking status. Booking status can be created, confirmed, payment failed, completed, etc. Payment status, I have kept one extra payment status. We don't need it here because we are having a simplified design, and in this booking status only I have added payment failed. Next, created and updated at timestamps. So these are the new tables we need for booking. So now how we'll update this room availability details or room inventory? So for that I have added one inventory service. So this is also listening to this inventory queue. Whenever a new hotel and room details are added and it is being updated as available for next month on upcoming sometime. So this inventory service will store this available counts in this SQL DB, and when the new bookings will come, the this book available counts will be updated by this booking service. Now, what all steps booking service will perform for a booking? So the first thing it has to do is it has to create one booking table entry, right, with the booking ID and other details, and booking status will be created. Then to complete the booking, it has to first check whether the inventory is available, whether the available room count is greater than the number of required room count, right? So after that, if it is there, then it will reduce the available count, then it will initiate the payment for using this payment service. So payment service can use some third party service to actually make the payment, and once the payment is completed, booking service has to change the booking status to be confirmed. Now these are the steps I have written here. Create a booking table entry with status created, check if inventory available, reduce it, and use locking to handle concurrent request, because you see in this table we are checking for the available count. So here we are actually looking for the available count, right? We are checking if the available count is greater than the required room counts, then we'll satisfy this current request. Let's say we are having two rooms available for this room type. Now two parallel requests are coming, both needs two rooms. So how the updates happens is basically first one request reads the value, this available count, it updates it. If it read 2, then it will reduce it to 0, and then it will write it back and commit, right? So before it commits, if the other request reads the data, so that request also read 2, again it will reduce it to 0 and it will write it back. So after both the concurrent requests, the value will become 0. So initially we had 2 and we needed 4 room types, and we satisfied that, but we don't have that many rooms, right? So this is a race condition, right? So for that we need locking. Usually we use pessimistic locking, that is preferable. We can use optimistic locking as well if the right contention is not that high. Now next step is initiate payments using the payment service. When payment completes, book table entry status will change to confirmed. Now what happens if payment fails? Booking table entry status we have to change to be payment failed. This status has to change to be payment failed. And also we have to inventory count should be incremented. So this available count we have reduced, right? So we have to add it back because payment has failed. Now basically if the this is a distributed transaction happening, right? And there are different ways to do that using two-phase commit, like saga pattern in event driven architecture. So we are using a microservice based architecture. It's preferable we use the saga pattern. So basically after every operation, one events will be emitted, and then for the next action we'll listen to those events, and based on that we'll perform the next event. So if a payment failed event is emitted, so booking service will listen to that, and then it will go back in this database and it will update the available count, it will increment it back, right? So but next one more problem we have here is, let's say the customer has closed the browser, or we are not sure if the payment has succeeded or failed, but we have not received any response from the payment service. So how long we should wait before we increment the available count? Because we have already decremented the available count because we want to satisfy that booking, right? And then we initiated the payment, but then we are waiting indefinitely and we have not received any payment success response or payment failure response. So should we keep the available count reduced? There should be a timer for that, right? So after that amount of time we should increment the inventory back. So there are different ways to do that. For that we actually use one Redis TTL. So in Redis we put one payload, like this is the booking ID and expiry time. So this is the booking ID, and let's say we will have a timer for 10 minutes or 15 or 20 minutes. So let's say that at that time this payload has to expire, and when that expires, then we'll check, like before that payment is successful, then we'll change the booking status to be confirmed. Before this timer expires, if the payment status is failed, then we'll update the status to be payment failed. But after the expiry time, when this is expired, that means we have waited for 15-20 minutes, then we haven't received any response, right? That time we also will go back and this database and will increment the inventory. Now one tricky situation we have here is, let's say after expiry we have incremented the inventory and then the payment service response has come, and that is success. So after expiry we have made the booking status to be failed, and then we see the payment has succeeded. What we will do for those payments? So there can be a separate cron job that can find those types of transactions and refund that amount back to the customer. Otherwise we can have a discussion with the interviewer, and as the payment is already successful, we can create a new request for this new booking request for this customer. Now one quick thing I want to mention here, so about this Redis TTL. So the Redis payload, the expiry time is set here as 10:10, right? So it will not exactly expire at this time. So it can expire after some time. So Redis periodically checks for expired items and then expires those items. So in our case, it can happen that the payload is expiring after some time, after the expiry time. But in our case, this is not harmful here, because we will be waiting for the payment little bit longer, right? So this is not harmful here. So next requirement is view bookings. So customer can use this view booking page to view the bookings. So for that we are using a separate service, booking view service. So I'm not using the same booking service because this booking service is taking care of the rights, the booking creation. So, and this is bit complicated. It has to talk to this multiple tables, and it has to initiate the payments, and all this has to happen consistently. So I'm not disturbing that service. So, and we are using a different service for viewing the bookings. This booking view service will read the data from this SQL database, but also we can improve this. So we can also use this cache. So anyway, this Redis cache we are using for this Redis TTL to expire the this inventory timer payload, right? But we can use the same cache to store the recently created bookings, and booking view service can access the details from this cache. If it is not there, it can access the details from this SQL database. One more thing I want to add here is can have a archival service, and where this archival service will move the past data from this SQL database and move it into this Cassandra database. And based on the view booking request, if it is a recent request, it can be fetched from the cache or database, or otherwise it can be fetched from this archival database. Now one more requirement we missed, that is the reviewing. Like customer can provide reviews for the hotels. So for that I have added one more table that is having ID, hotel ID, user ID, rating, and comment created at. We can add room type ID as well in this table. So we can use the review API we already discussed earlier, and using that customer can provide the ratings. Now we have almost satisfied all the requirements. Two minor things are remaining, that's analytics or recommendations and notification service. So when customer has to be notified every time the booking status changes or any other type of notifications, right? The promotional notifications I'm not covering here. So every time the booking is happening, so the booking status change events has to be emitted in this queue. There is a separate queue I have drawn. So this is the booking queue. So this analytics service and notification service will listen to this queue. So this is for this analytics service will use this booking data for analytics and later for recommendation purpose. Notification service will notify the customers as the booking status changes. Every time search is happening, every time customer is searching for hotels, that search events also has to be emitted in this search queue, and analytics service will listen to this search queue. So based on the user search history also, some hotels can be recommended to some users. So this is the analytics and notification service. So I think we have satisfied most of our requirements. Let's just go through this once. So we are having this admin can add hotels rooms, customer can search hotels rooms, customer can book hotel, customer can list bookings, hotel and room will have amenities, customer can review rate hotels rooms, notifications, hotel recommendations, and all these are satisfied. About the non-functional requirements, eventual consistency for adding hotels and rooms. So the onboarded hotels and rooms details are getting populated in the Elasticsearch database. That time is very minimal, but this is still eventual consistency. Low latency for search, high availability for search. So Elasticsearch is very fast and highly available. Strong consistency for booking, must prevent overbooking and enforce accurate availability. So we have satisfied all these conditions in our booking design. Scalable, the system is scalable. One requirement, one non-functional requirement I have missed here, that is idempotency of booking. So if customer is trying to book with the same parameter again and again, so we should not create different bookings for that. So how do we satisfy that? So consider this booking table here. So how can we say if two requests are the same booking? So based on these parameters, right? User ID, hotel ID, room type ID, number of rooms, number of guests, check-in date, check-out date, amount, currency. So if all these parameters are same, right? So that means we can assume this is the same request and this is a duplicate booking for the same customer, right? So in that case, how do we handle that? So one thing we can do is we can have a idempotent key. So this is the booking ID, right? This booking ID we can create in a different way. Consider we'll create one hash from all this parameter, and using that hash we'll be creating this booking ID. So next time if one more request is coming with the same parameters, the hash will be same and the booking ID also will be same. So it will not create a different booking for the same customer as same parameters, right? Because this booking ID is the primary key of this table. So with this, we are done with the system design of hotel reservation system.